For Scientific American Science Quickly, I'm Rachel Feltman. "20 years ago, Hurricane Katrina became one of the deadliest storms ever to hit the U.S. After sweeping along the Gulf Coast, wreaking havoc in Louisiana and Mississippi, the massive storm ultimately led to 1,392 fatalities, according to the National Hurricane Center. Katrina's destruction centered on the city of New Orleans, where failing levees and flood walls left most of the city underwater and displaced nearly all of its residents, some of them permanently. The catastrophic aftermath of Hurricane Katrina was the result of numerous failures. Failures in infrastructure, city maintenance, emergency management, and more. But the worst thing about this disaster might be that scientists saw it coming several years ahead of time. And one of Scientific American's own had even tried to help spread the word. Mark Fischetti, now a senior editor at Scientific American, wrote about research on the inevitability of disaster in New Orleans for the magazine back in 2001. He's here today to tell us about his experience covering the tragedy and how New Orleans hurricane preparedness has evolved in the 2 decades since. Thanks so much for coming in to talk with us today, Mark.
It's my pleasure to be here.
So, as a science journalist, you had an interesting connection to Hurricane Katrina. Some folks actually pegged you as the guy who predicted the disaster. Can you tell us more about that?
Right. So Katrina was in 2005, August 29th. In 2001, I had written a feature story for Scientific American about hurricanes crossing the Gulf of Mexico. And if one particular hurricane path led into New Orleans in a certain way with a certain strength of storm, it would put the city under 20 feet of water. This was based on science papers, lots of models from scientists. The story came out, didn't get much attention until Katrina hit, which was Monday, was the 29th of August. Right away, the disaster was so tremendous. So many people were already being reported as dead, killed, missing, and the various levels of government already were getting criticized heavily. And there were statements made essentially that no one could have predicted a storm like this. No one could have predicted that the destruction in the city would be so bad. And the New York Times found my article from 2001 and said, well, actually, someone did predict this. So they called me on a Wednesday, wanted me to write an op-ed for Friday's newspaper, which I did, and basically said all of this had been predicted, not by me,
sure.
But by scientists who had done all the studies. As soon as that op-ed was out that morning, my phone was off the hook. And for 2 weeks, I was on radio, TV, all across the country, outside the country. And every single time, whoever was talking to me wanted to say, this is the man who predicted Hurricane Katrina. And every single time I said, no, it wasn't me. It was the scientists. And please, please, people, listen to scientists, listen to science, because a lot of this could have been prevented.
Right. The important takeaway is that there are scientists putting out these studies all the time saying, pay attention to this potential disaster.
All the time. I mean, the studies and the storm tracks were there to be seen.
Yeah. Well, so since you were, so immersed in this as it was breaking catastrophic news, can you give us a refresher on why Katrina was so destructive? What was it about the storm and how it swept through New Orleans specifically?
Yeah, so New Orleans is a bowl. It's all below sea level, but it's not on the sea. There's miles and miles and miles of wetlands, or there used to be, between the city's whole southern side and the open water of the Gulf of Mexico. And those wetlands centuries ago were solid, dense wetlands. So what wetlands do for storm surges, which is what really flooded New Orleans, they break down the storm surge. So the more miles of intact wetlands you have between a city or any municipality and the open water, they cut down the storm surge. But for decades and decades, the wetlands have been deteriorating for 2 reasons. One is that the Mississippi River, which comes from the north to the south and empties just south of New Orleans, runs around the southern side of the city. And there are levees on both sides of the Mississippi for its entire length. Levees are big, long, parallel hills of dirt and concrete that run on each side, each bank of the river to prevent flooding. Most major rivers flood in the springtime. So over a lot of years, the Mississippi was walled in essentially. So the flooding didn't happen anymore. But the flooding is what sustains the wetlands. The sediment and the fresh water from those floods annually and in between the annual spring floods reconstitute the wetlands, keep them healthy, keep them thick, keep them vibrant. And that hadn't happened for so long that the wetlands were deteriorating extensively. So those miles and miles of buffer really didn't exist much anymore. And on top of that, the Army Corps of Engineers primarily cut all kinds of navigation channels through those marshes to allow for shipping, to allow for fishing, lots of industry, oil and gas industry lines. And that just created more shattering and tattering of the wetlands.
And so looking back now, 20 years later, what are some of the big questions that you wanted to explore as a reporter?
So, the big one obviously is New Orleans safer now than it was then? And the answer is yes and no. What happened was I went down again to New Orleans in the first few months after Katrina to see what could be done, because that was the question, right? What could be done? First of all, how could this have happened so badly? And then what could be done to prevent it? So a few months after that, we published another story in Scientific American called Protecting New Orleans. The first one was Drowning New Orleans, which basically presented three plans, three potential lines of defense that could be built to better protect the city. There was a lot of infighting already down there, not uncommon down there, between all kinds of political parties and commercial parties. But some people who worked with the governor's office and the city's offices actually helped me convene these people. And that's where these kind of three alternatives came. Finally, the state of Louisiana created the Coastal Master Plan, which kind of outlined somewhat similar plans of restorations that could be done. So the plan is basically got two parts. It's hard structures to protect the city directly. So big gates that can be closed when storm surges are coming, more bigger, higher levees, flood walls, which the lower Ninth Ward is the place that got so heavily flooded and where so many people died. In that case, there are flood walls. There's like corrugated metal walls that run along navigation channels and things that just toppled over. So stronger walls, bigger gates, things like that to protect the city. But the second part was how to reconstitute the wetlands, which ultimately are the biggest buffer and barrier to hurricanes.
And I know when you set out to answer the question of whether New Orleans is safer now than it was in 2005, you talked to a particular scientist. Could you tell us a little bit about her and what she studies?
One of the people I spoke with was Alicia Renfro. She's a science and policy manager at the National Wildlife Federation, which has been working with the state of Louisiana for 20 years now on how to optimize protection and largely restoration of the wetlands. And the National Wildlife Federation basically tries to make sure that proposed projects, and there are lots of them, are based on the latest science.
And what does she say has changed about our approach to hurricanes since 2005?
I think what people realized, amongst many things from Katrina in particular, was the storm surge is what really ends up killing large numbers of people, at least in coastal cities. So that really wasn't taken as seriously as it should have been. So that's the biggest change, I think, is that scientists, engineers realize that that's what they have to be most concerned about. This lesson's been learned over and over again. When Hurricane Sandy flooded New York City and New Jersey, again, it was the storm surge that did all the damage. So that's really been what's changed in how to protect urban areas in particular against hurricanes.
And how has this approach impacted the infrastructure in New Orleans?
There's been a lot of work to build physical barriers and other protections like that. And I talked to Alicia about that.
There's been about $14 billion worth of upgrades to that giant levee system that surrounds the greater New Orleans area. This included improvements in addressing some issues with some of the flood walls, putting gates along the canals that can be closed during storm events. There was a storm surge barrier that was built across an area called the Golden Triangle on the eastern flank of the city, which is where that storm surge was funneled up into this area, flooding into New Orleans East, as well as the lower Ninth Ward in St. Bernard Parish. And then there's also been major investments in coastal restoration around Louisiana, some which benefit this area and help restore that natural system that in turn protects that infrastructure that we've invested in to protect the system.
So that's all been very successful. What has not happened is rebuilding the wetlands.
What planned projects are still incomplete?
There's a lot. I mean, that coastal master plan has dozens of projects, and they're ranked, and some of the highest ranking ones were floodgates and things like that in the city. There were a number of diversions, they're called. So if you think about the levees along the Mississippi that stopped the flooding, the idea is to put a gate in the southern wall, the wall of the Mississippi River that's away from the city and faces the Gulf. Put a gate every once in a while, big gates that stay closed most of the time. But during the spring or occasional other times when there's high water, you can open the gates and let some of that river water with the sediment and nutrients wash out over the vast areas of wetlands to try to help rebuild them. It's been done in a few places, including southeastern Louisiana. They can be effective. They take a long time to do that rebuilding. But there are a number of diversions planned. The biggest and the most advanced one was called the Mid-Barataria diversion. And it actually had gotten started. It had funding. They were starting the actual work. All the permitting was done. And a few weeks ago, the state of Louisiana canceled it.
Did Alicia have any sense of why these projects have now recently been canceled?
I'll let her speak to that.
So the state cited cost as the issue, and it is an expensive project. It's about $3 billion for the project. It's fully funded by Deepwater Horizon. I don't know if I buy completely that cost was the issue. It is a controversial project in some realms because it is a ecosystem transforming project. They had actually started construction back in August of 2023, and then the state just halted it. That comes at a real disappointment. You know, I think a lot of us have been working hard to advocate for this project for a long time and see this as a real long-term, large-scale solution to restoring coastal wetlands. It's not the only project we need. It wasn't going to solve the entire land loss crisis problem, but it was going to put that sediment back to work in a sustainable way to not only build wetlands, but sustain the existing wetlands today, tomorrow, and even 30 years from now.
So all in all, how does this leave New Orleans in terms of preparation for another storm like Katrina?
I think physically there's better protection. I also think that societally there's much more reverence. I mean, the joke for a long time in New Orleans was, there's a hurricane coming. Well, let's have a hurricane party. We know we're going to lose the power, so get ice, get coolers, get your drinks, pack it all in there. Maybe think, well, if there's some water, go sit on the roof, have a party. This was legion in New Orleans and the area. And that attitude has changed. There were tens of thousands of people who did not evacuate. There were mandatory evacuation orders just before Katrina hit. Most people didn't pay attention or heed them. Now that's different. So that alone is going to make a big difference.
And 20 years later, what kinds of impacts are we seeing from Katrina on the people who live in New Orleans?
Well, a lot of them left when the storm came after the storm damage. A lot of them had left the city, and there was literally nothing to come back to in the lower Ninth Ward and some other areas. And a lot of other people who had left just kind of got panicked by the whole situation. Hurricanes come through the Gulf every year, and so they just didn't return because they didn't want to have to confront that sort of thing again. So the population of New Orleans now, today, 20 years later, is still about 20% less than it was the day before Katrina.
Well, thank you so much for coming on to talk through this with us.
Glad to be here. Thank you.
Now we'll check in briefly with Andrea Thompson, a senior news editor for sustainability at Scientific American. She's here to give us some more context on hurricane preparedness in the U.S. and how recent government funding cuts could impact our ability to predict and survive storms like Katrina. Thanks for coming on to chat with us.
Thanks for having me.
So how have hurricane seasons changed in the last 20 years?
So, the 2005 hurricane season was really a standout season. We hadn't really seen anything like it. It was just a blockbuster. There were a record number of storms at that time. It was the first time we went through the whole hurricane season name list and had to use Greek letters. and still holds the record for the most Category 5 storms in one season, which was 4. And one of those, Wilma, is still the most intense Atlantic storm on record. So it was just a standout. And at the time, researchers were really only beginning to think about climate change and the interaction with hurricanes. And Katrina and that season really actually launched a ton of research into it. So over the 20 years since then, we've accumulated a lot more data and put a lot more research into understanding how our hurricane season's changing. And of course, we still have year-to-year variability in the number of storms and how strong they are because, in addition to climate change, you have natural climate variations like El Nino that have an effect on storm formation. But overall, we're seeing that storms are getting stronger, they're wetter, and they're moving slower. So basically, intensity is shifting towards the higher end of what's called the Saffir-Simpson scale. So that Category 1 through Category 5 hurricane ranking system. So we're seeing a higher proportion of the more intense storms than we did in the past. We are also seeing more rainfall intensity. We see that not just in hurricanes and regular rainstorms too, because the warmer atmosphere, there's more moisture. So when there's rain, there's a lot more of it to come down. So we have higher chances of seeing flooding like we did in Hurricane Helene last year or in Hurricane Harvey. Storms are also moving more slowly, which means they have more time to pummel coastal areas and to potentially dump rain on those areas. If it's sitting over one area for a long time, like Hurricane Harvey did, that rain is just going to keep hitting the same area over and over. There's some sense or some indication that storms are hitting their peak intensity closer to shore, which is obviously bad for places that are at risk. And they seem to be weakening more slowly once they make landfall. So they're holding on to more of their strength as they move inland, which means places further inland potentially see more damage. And one thing that's particularly concerning is that more storms seem to be undergoing what's called rapid intensification. So that's when the maximum wind speeds in a storm increase by at least 35 miles per hour in 24 hours. It can be a lot more than that, and some storms have done that. And that's really dangerous because if you're expecting a Category 1 hurricane, either as an average citizen or an emergency manager, and suddenly you have a Category 3, you have less time to prepare for that. And so that can take people by surprise. So it's a big concern.
Yeah. Well, and how has our preparedness for serious storms changed since 2005?
So it's definitely a mixed bag. So in some ways, namely in forecasting, we're better than we were 20 years ago. And Congress dedicated money into improving hurricane forecasts, in part because of Katrina. And so there's been a lot of work on forecasting models. And so the track forecasts have improved by almost half. So the track is sort of where the hurricane's going to go. And the intensity forecast, how strong it gets, are about 30% better than they were back in 2005. So those are substantial improvements. And that means people have more accurate information earlier on to be able to make decisions like, does this area need to evacuate? Do I need to board up my house? You target people who really need to know about the storm versus, letting one population know and then the storm actually moves over. So that's been really sort of a bright spot. But in other ways, we might be less prepared because we have a lot more people and a lot more infrastructure on coastal areas. And those people aren't always experienced with storms. So they may not know everything they need to do. And at this particular moment, emergency management in this country is very much in flux. It's unclear how much FEMA will respond to storms. There was already a staffing shortage before the Trump administration made cuts. And the idea is the federal government now wants local and state emergency management to handle more of these disasters. But that capacity just doesn't exist in a lot of localities because there isn't the funding or the staffing to support it.
Yeah, well, like you were saying, the National Weather Service has faced a lot of cuts recently. So how have those impacted our hurricane readiness?
So it's a little hard to tell. The cuts have not been as deep at the National Hurricane Center as they have been to NOAA and the National Weather Service more broadly. So those forecasters are still there, still making those forecasts, which that's good. But you also need the local forecast offices because they take what comes from the National Hurricane Center's forecast on the hurricanes and make the more detailed local forecasts about who's getting storm surge, telling which areas and people to be, on the lookout. They are the ones that coordinate with local emergency management. So there are a lot of concerns, and some of the offices that have seen a lot of cuts are in hurricane-prone areas. There is some talk about trying to shift personnel, but you also can't just think about the offices that are on the coast, because when you're talking about understanding hurricane forecasts, you don't need to just understand the hurricane itself. You need to understand the larger atmospheric environment it's in, which means we need to do things like launch balloons from Iowa. And you wouldn't think, weather information from Iowa helps us learn about this hurricane that might hit Florida, but it does because it helps us if there's a high pressure system coming in that might change the path of the hurricane. We need to know that. Even though the cuts at the National Hurricane Center haven't been as bad, they haven't been able to do their training with local emergency managers, and there can be turnover in those positions from year to year. So you may have an emergency manager who doesn't know the ins and outs of what the National Hurricane Center gives them of the information and how to best use it. So that has been a big concern I've heard from hurricane experts. And then, beyond this season, there are a lot of long-term concerns because if the cuts to basic research that have been proposed go through, we won't continue to see the improvements in the forecasting and modeling that we have seen, and we could actually see degradation eventually. So that's a huge concern, even looking out past the 2025 season.
Well, thanks so much for coming on to talk us through this.
Thanks for having me.
That's all for today's episode. We're off on Monday so we can all enjoy the long weekend, but we'll be back with a new episode on Wednesday. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi, Kelso Harper, and Jeff DelViscio. This episode was edited by Alex Sugiura. Shayna Posses and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Rachel Feltman. Have a great weekend.